So normally the antenna is connected directly to the output of the SI5351. This is the antenna lead here. I just tacked a couple capacitors here on the end of the wire. Two values. One's a 0.01 and one's a 0.1. And we're going to see what our readings are on the other side of the capacitor. If you remember, right here we've got about a -16. Alright, so let me change it to the other side of that capacitor. And it went away. Let's look at the second harmonic here. That would be 28,191. And as you can see, we're on 28,191, but we see no signal there. Let me go back to the other side of the capacitor. That's the back side of the capacitor. You can see we have a second harmonic. Let's go back through the capacitor, and we have nothing. That's through a 0.01. Let's go through a 0.1. All right, so there's a 0.1. We have nothing. Let's just step it up to the fundamental frequency, which is going to be 14.0956. There you can see. Now we've got a solid 10 dBm. If you remember a minute ago, we had about a 9, but now we got a solid 10 dBm. Let's go. Let's take the capacitor out of series, out of the antenna. We're going to take the capacitor out. We're going to just connect without the capacitor, and you can see we actually dropped a little, about to 9 dBm. Let's go through the capacitor. Through the capacitor, we got about a good solid 10 dBm, and through the capacitor we have no second or third harmonic that we're measuring here. So let's just think about this a minute. So, you know, 10 dBm, let's look at 10 dBm here. So 10 dBm is 10 milliwatts. If we were only getting 9 dBm, hey, that means we're only running about 7.9 milliwatts. And if we were actually getting closer to 8 dBm, that means that our output of the tracker would be about 6 milliwatts. So it looks like the capacitor in series, cleans the signal up. It takes the second, third harmonic out pretty much, and it helps bring our output up just a little bit.